Hello class, today we're going to be on 1.5 and 1.6, determining limits by plugging in and factoring. So when we are determining limits algebraically, there are quite a few methods that we'll need to know in order to find limits, but these are the two main methods, and the easier methods, to be honest. So we can determine limits by plugging in the given value as long as we don't get 0 in the denominator. However, if we do get a 0 in the denominator by plugging in, try factoring. So let's go over these two more basic methods. So here we have the limit as x approaches 3 of x squared plus 2x minus 3 divided by x minus 1. So I'm just going to go ahead and try to plug it in and see what I get. Okay? So I'm going to plug in, let's see, no, we're plugging in 3. So 3 squared plus, no, I'll put it in parentheses, plus 2 times 3 minus 3 equals 3 minus 1. And as we can see, we won't be getting a 0 in the denominator because 3 minus 1 is 2. So we can keep going. Let's go ahead and simplify this and see what we get as the limit. So 3 squared is going to be 9 plus 2 times 3, that's 6, minus 3 divided by 3 minus 1 is 2. And then 9 plus 6 is 15 minus 3 is 12. So we're going to have 12 divided by 2, which is 6. So the limit as x approaches 3 is 6. What if, though, we plug in a value and we get 0 in the denominator? So what if we take this same function, but instead of trying to find the limit at x equals 3, I want to try to find the limit as x approaches, or not equals, as x approaches 1 of x squared plus 2x minus 3 of x minus 1. So notice right away that if I plug in 1, and you always want to plug it in first, see what you get, right? Or just do it in your head if you can. In this case, it's pretty easy to see. If I plug in 1 in for x, it's going to be 1 minus 1. That's going to give me a 0 in the denominator. So I'm going to have to do a little bit of algebra first to kind of manipulate this equation in order for it to work for me. Okay? So what we're going to want to do is we're going to want to try to factor this top part. Now remember, when we did factoring last week, if we have a 1, or if a is equal to 1, or if there's no number in front, we can use the easier method, where we just need to find two numbers that add to the middle number, but when multiplied, we get the last number. So remember, I like to create my little tree here, and 3 is really easy. There's only 2 factors to 3, and it's 1 times 3. But we're multiplying to a negative 3. So remember what that means in terms of the rules of multiplications of negatives and positives, or of integers, and that is that to multiply to a negative, one of these needs to be negative. So which one, if 1 were to be negative, would they add up to positive 2? And in this case, the 1 would have to be negative, because negative 1 plus 3, or 3 minus 1, is positive 2. If I did it the other way, I'd get negative 2. So now I can go ahead and factor this top. Now, every time that you rewrite the limit until you plug in values for it, you want to write the limit as x approaches 1. So it may get a little old writing it over and over every time, but it's common mathematical courtesy. So I'm going to rewrite this top part as x minus 1 times x plus 3 divided by x minus 1. Now we can see that we have the same factor on top and the same factor on bottom after we factored it. Now this is a beautiful thing, and this is why we factored it. Because now we can actually cancel this out, and what we're left with is the limit as x approaches 1 of x plus 3. And then now we can plug in 1 and see what we get. So plugging in 1, we get 1 plus 3, and that equals 4. So our limit as x approaches 1 is 4. Pretty cool stuff, huh? It's kind of a cool thing to be able to play with the mathematics. Not change it, but just play with it so that we can cross things out, make it work for us. Okay? Let's move on to a few more examples, because you'll be seeing some different kinds of looking things. And let's say now that I have something like this. I want to find the limit as x approaches 0 of 3x squared plus 4x minus 1. Well, here we won't run into the problem of having a 0 in the denominator, as you can tell, because, well, there is no denominator. So let's just go ahead and plug in 0 and see what we get. So 3 times 0 squared plus 4 times 0 minus 1. 0 squared is still 0. 0 times 0 is plus 4 times 0 minus 1. Well, these zero out, don't they? 3 times 0 is 0, 4 times 0 is 0. So what we're left with is just negative 1. So our limit as x approaches 0 of this function is negative 1. Okay? Let's take a look at a few more. And we'll take a look at something like this. Say if we want to find the limit, again as x approaches 0, but this time our function is 5x squared minus 3x divided by x. We can see immediately we'll run into the problem where if we plug in 0, we'll have 0 in the denominator, so that's not going to be an option for us. Let's see if we can factor this thing and try to figure out what's going on. So notice that this is a binomial on top, that there are two terms. So let's see if we can factor a greatest common factor out. And we did this last week when we were dealing with factoring. It was a small portion of one of the steps to factor. So remember, I can take, this is just my scratch work off this side, I can take something out of both. And in this case, the greatest common factor between 5 and 3 is 1. And the greatest common factor between x squared and x is just x. So I can pull out of 1x, or just x. Remember, we're really dividing this x out. I want to wait till it focuses again. Try my hand. Okay. So, perfect. Okay, so we have 5x squared divided by x. I'll try it again. 5x squared divided by x, that's just going to be 5x. And then negative 3x times x, or sorry, negative 3x divided by x is just going to be negative 3. So what we can rewrite this thing as this. So we can say the limit, remember I need to write it because I haven't plugged anything in yet, x times 5x minus 3 divided by x. And as you can see, we can cancel the x's out. It's a beautiful process, isn't it? So we're left with the limit as x approaches 0 of 5x minus 3. And then now we can plug in 0. So 5 times 0 minus 3, well 5 times 0 is 0, so our answer is negative 3, just like that. Okay. So let's go ahead and do one last example, and this is going to be a quick example. Just you'll probably see something like this, so I just want you to know what to do with it. The limit as, let's say, x approaches 4 of 2. Well, in this case, notice that there's no variable that we can plug anything into. So when that is the case, our answer is just whatever we have. So in this case, the answer is just 2. Okay. Just wanted to show you that. All right, so that's all I have. Have a good day. Let me know if you have any questions.